We've seen with the three-phase induction motor how the three-phase supply produces a rotating magnetic field within a motor stator. The problem is, what do you do if there's no three-phase supply available, or its presence would be unsafe, such as in the office or in the home? Well, you have to use a motor operating from a single-phase supply, in which the rotating field is emulated. An induction motor with a single-phase winding would have no starting torque whatsoever. Now in this demonstration, I've disconnected two of the phase connections from a standard three-phase motor. When the motor is switched on, it makes a great deal of noise, but does not spin. This is because there is no movement between the magnetic field and the rotor bars, and so little current is induced into the rotor. Now if the motor is spun by hand, the movement between rotor bars and the magnetic field in the stator induces a current in the rotor, which produces an interactive magnetic field and so a torque, which will continue to drive the motor in the direction it was first spun. Now obviously it would be impractical and dangerous to start motors by hand, so a single-phase motor must use another method. The simplest single-phase induction motor is the split-phase motor. We can see that it is similar in construction to a three-phase motor and has a cage rotor and a laminated stator, but with a different configuration of windings. Here there are two sets of windings. This is the main or run winding, and this is the auxiliary or starting winding, and this is placed in slots at 90 degrees from the main winding. We can see that the windings have the same number of turns, but are made from different sized conductors. Because of this, the windings have different impedances, resulting in a phase displacement between the two windings. This difference in phase and position of the windings emulates a rotating field, which will cut the rotor bars and cause the rotor to spin. Once the motor is up to speed, the start windings are no longer required and are automatically cut out of the circuit by a switch which is housed in the end plate. The switch operates by centrifugal force, which causes these weights to fly outwards as the motor speeds up, making this bush slide along the shaft and open the contacts. This happens when the motor has reached about 80% of synchronous speed. Because the starting winding is short-term rated, this type of motor is not suited to applications where frequent starts are required, also because the motor has a relatively poor starting torque. It is, however, cheap and reliable, and often used for equipment such as bench grinders. A single-phase induction motor which produces a better starting torque for a smaller line current than the split-phase type employs a capacitor in the starting winding circuit. These motors are available with the capacitor arranged in three different ways: plain capacitor, capacitor start and run, and capacitor start. In the capacitor start motor, phase displacement is obtained by connecting the starting winding in series with an electrolytic capacitor, which is usually mounted on the body of the motor. The stator, rotor, and centrifugal switch are similar to a split-phase motor, although the proportions between the starting and running windings are generally different. With this type of motor, the capacitor is cut out of the circuit when the rotor reaches about 75% of synchronous speed. The capacitor start motor is capable of fairly severe starting duties, particularly where quiet starting is required. And although the capacitor will only withstand the supply voltage for a limited period, it can be left in circuit longer than the starting winding of the split-phase type. This means that up to 30 starts an hour may be permissible, so long as the starting time is not too great. Usually a second or so is sufficient. Capacitor start motors are probably the most common of all single-phase induction motors, and are used for very many applications, such as a lathe, where a constant speed drive is required. The plain capacitor motor is basically a variation of the capacitor start motor, but here the capacitor is left in circuit for the whole time that the motor is running, and so a centrifugal switch is unnecessary. This type of motor is sometimes referred to as the permanent capacitor motor. Plain capacitor motors are available only in smaller sizes and are used for such applications as certain refrigerator compressors, fans, and central heating water pumps. The capacitor start and run motor is probably the most efficient of all of the single-phase induction motors available. As in the case of the capacitor start motor, there are 2 windings, but in this type of motor, both windings are designed for continuous running. The other difference is that there are 2 electrolytic capacitors connected in parallel with the auxiliary winding. One capacitor is switched out of circuit when the motor reaches running speed, leaving the other capacitor in circuit to provide permanent power factor improvement.